All right, so this lesson gets into quadratics, quadratic functions. Basic quadratic looks like this. So f of x, again, that's our just function notation. You can put a y there. Ax squared plus bx plus c. I'm sure you've seen that before. So the ax squared part is the quadratic term. The x squared makes that the quadratic term. A, b, and c just represent numbers, by the way. The middle term, the bx, is a linear term. Of course, if we didn't have the ax squared, this would just be the equation of a line, right? And then the c we call the constant term. So some of the problems you'll look at today are just going to be very straightforward like this. Just identify, hey, is this quadratic or linear? And then what's the quadratic, what's the linear, what's the constant term? So in this example, now notice this is a linear times a linear, so we need to multiply this out first. So let's distribute this through. Let's take the x through both of these. So I would get x squared plus 5x. Then I'm going to take the negative 3 through both terms as well. So minus 3x minus 15. Of course, if I clean that up now, we'd get x squared plus 2x minus 15. Of course, I've got my f of x out here. Now, very clearly, this is a quadratic, right? So here is the quadratic term, this very first one. This is the linear term, and this is the constant term. Okay, so not too bad. Now, there's some key characteristics to quadratics. So the graph of every quadratic is a very characteristic shape. It's called a parabola. Again, I know you've seen these before, but a parabola. Couple key things about parabolas. They're symmetric. It's like they're looking in a mirror. So the axis of symmetry is this kind of dotted imaginary line. It divides that parabola right in half, and it makes both sides, again, like a mirror image of one another. The axis of symmetry cuts it again right in half. It passes through the vertex. So for a parabola that opens upward, the vertex is going to be that lowest point. If you had a parabola opening downward, then of course it would be the highest point or the maximum, right? And you could have either one. So the vertex, again, key point, axis of symmetry, just going to be x equals something because it's a nice vertical line. Again, pretty straightforward. Just identify a couple of key characteristics there. Now, because parabolas are symmetrical, there are corresponding points on opposite sides. Let me show you what I mean. So here's a little example. It says identify the point corresponding to P. So here's point P. Well, what corresponds? It's just its mirror image over there. So here would be the axis of symmetry, dividing it in half. So there would be its mirror image. What point is that? Well, it looks like 1, 5, right? X equals 1, y equals 5. And so that would be the winner there. Now what if they ask for what's the corresponding point to Q? Well, again, you just come straight across. It's just going to be directly opposite that axis of symmetry. And in this case, it would be negative 2, 8, it looks like. That would be the corresponding point to Q. Now, how about something like this? Use the quadratic to predict y if x equals 6. Well, really, they're just asking you to evaluate a function. They want you to go plug a 6 in everywhere there's an x and see what y equals. So very straightforward. You've done things like that before. So let's plug this in. Again, I'm just replacing the x's with a 6. And again, you can go plug that through a calculator, right? So 2 times 36, that would be 72 minus 12 minus 2. So 72 minus 12 is 60 minus 2. So it looks like 58 would be the answer there. So, but again, you could just go run that through a calculator if there's any question. Okay, not too bad. They're also going to talk a little bit in the lesson about finding parabolas from 3 points. Just go through the lesson. Don't stress about that. I'm not going to have it on the practice assignment. It's not that big a deal. Okay, so have a great lesson.